example, you could define special areas in a picture and add this information to the attach it to each buffer, but it could be something else completely, some information for the MPEG parser or whatever. So it can be defined, it can be extended by developers. We can also we have daily processing in 1.0. It's very important. So it means that instead of modifying the buffer, you can add extra information to it, and then later it will be processed. So for example, in this image, you can declare that really the only region you care about is a subset, and then only at the very end will this image be cut, and let's say by a hardware accelerated device, instead of doing it in the middle of the pipeline where we would have to do it in software. Another big feature is portfolio pass-through. So that's very useful if you have hardware decoding or audio. So instead of always finishing giving decoded data portfolio, for example, we can give MP3 if you have a Bluetooth headset. So you can save power on mobile devices. Gstreamer 1.0, big improvement. It makes it much easier to do dynamic pipelines. So dynamic pipeline means changing elements in the pipelines while it's playing, while it's running. So among these things, previously you had all the context was sometimes attached to the buffers, but sometimes just in events that had passed through the pipeline at some point, that every element had to remember. Now the core, the paths, which are the things that connect the elements, will remember that context. So if you remove one element and put a new one, then all this context will be pushed into this new element automatically. And renegotiation is much easier now. That means that if you set up your pipeline to place on format, and you change one element in there, and you can renegotiate it because the elements will negotiate at when they start playing what format will it be. So if you change something, you can now much more easily renegotiate it and possibly change the format. For example, if you output to a stream, you might want to negotiate RGB, but if you want to do something else to encode, you might want to include a different color space, and these things are potentially dynamic in your pipeline, so now it's much easier to change that at runtime. Another big improvement for developers is improved path probes. So in 1.0 and 0.10, there were two different ways to act on the data from the application without writing a custom element. One was that you could block the flow through a path and completely separate the second one, that you could have probes to see what data flowing through. Now all these things are brought together, so you can do it, and you can actually modify the buffers going through without having a custom element. That's very useful for applications to do all kind of interesting things. So you can look at the buffers passing, and only when you find the specific buffer that you want, then you can block the pipeline and modify it, for example. Because you have to block the processing in the pipeline to be able to modify it, because it's multi-threaded. So now these were like my personal highlight of 1.0. There's a lot more new features. Next, I will go first at the more end-user oriented features of 1.0. So features for users. And then I will come back at features for developers. So these are features that are really end-user features, I think. My favorite this week is HTTP fragmented playback. That means HTTP live streaming, the Apple format, the thing that you have to use if you want to stream to iPhones and iPads. And we now have also support for two other very similar technologies. One of them is Microsoft full streaming. So these are all playback support for now. We have kind of server support for HLS. And we have patches that are being merged now to support MPEG dash and smooth streaming. So yes, so MPEG dash is a bit like HLS, except instead of using a playlist, the playlist is an XML store it in Silverlight. We have a player for that. We don't have any of the VRAM, obviously, but we have all the open source bits, all of the standard bits. Another big thing that's coming to 1.2 is finally we should have decent desktop GPU decoding. So you can use your Intel GPU to decode the video, H.264 mostly, I guess, Big 2, etc. That work was done in a large part done by Intel. So thanks Intel for helping us. We have VPU support done by the community. So that is ongoing. So I don't know if it will be 1.2 or not. Ideally, the whole GPU decoding thing should be more or less transparent to the end user. And if the developer uses decode bin or play bin or one of the autoplaying elements, it should be transparent to the developer. It should just work. We're very happy about that. We had hardware decoding on mobile platforms for a long, long time, on embedded platforms. But it was basically very less flexible than what we have now. But now we can use it on the desktop, meaning that you can have the same software, and if it's like an NVIDIA card, it will use the NVIDIA software, and if it's an Intel processor, an Intel GPU, to do the Intel thing, and ideally we'll have the AMD API one in the future when someone gets to it. Some of the features that were in 0.10 were never ported in the 1.0 timeframe, and now we've brought them back for 1.2. Among them is OS X audio support, playback for professional MXN format, producing MPEG program stream files, such as those used for DVDs, and playback there are arcade subtitles. I don't know if these are popular here, but they're interesting. Next thing is developers. So all of the features I talked about now were quite visible to the end users. These next features, they're not so visible to end users, but they are, I think, quite interesting for developers. First, we have much better support now for mobile platforms. For these two platforms, we actually have merged support for most of the possibilities of these platforms. So on one side, our Android support is more or less complete. We have access to the hardware decoders and coders if you have ice cream sandwich, because there were no APIs before. We have audio source and things based on OpenSLES, so that's the NDK. And we have EGL video sync, so you can draw to the screen. But basically, you can write full Gstreamer applications and put them on the Android market, and they will work on all the Android devices. There are already some very big applications on the Android market using Gstreamer. For example, Cisco Jabber for Android, and also Cisco Jabber for iPad. So iOS support, we have video source now, we have EAGL, which is Apple's version of EGL, support in the video sync. We don't have access to hardware decoders. I think there's no APIs for that. They're easily usable. We have better Windows support. The Directory desync has been improved a lot. I've also seen today some patches for OS X came in. So some improvements there also. We also have more support for other embedded platforms. Lots of work has been done on the OpenMac support for the Raspberry Pi to talk to their video core main processor, really. That does all the video and everything. So that's really where we have been doing a lot of work with Raspberry Pi Foundation to make these things work. And we have recently been improved the MFC support. So that has a support for the Samsung Exynos chips for encoding and decoding video and hardware. So So these should now work. We've been doing that also in the last couple of weeks, months. We have improvements also in the hardware support. This first one is Bluesy. So previously, the Bluetooth support was in a separate Bluesy package. So it did not get much support from Gstreamer developer because we didn't see it. It was not in our repository. It was in Bluesy repository. Now they have a stable API in the Bluetooth stack so that the Gstreamer part can be in the Gstreamer repository and be updated by us. Another thing I'm quite happy with is finally we have support for H.264 incoming cameras on the desktop. So there's a standard called the USB video class support for H.264, UVC. So almost all of the USB cameras in the market are UVC. They now have an extension to support H.264. The only camera on the market I know that supports it is a Logitech CN920. So if you plug it, you can get the H.264 encoded in 1080p from the USB camera and make video calls using that without having to. So you can 1080p video calls on a relatively small device. We did a demo a couple of months back on an OMAP 4 platform, the Panda board, of 1080p video calls with encoding on the camera and decoding on the hardware development platform, all that with Gstreamer. Using empathy, right? Unmodified empathy on a Ubuntu. Also, another thing that's coming is there's a new memory allocator in the kernel called DMA buff that allows you to allocate buffers that are DMA mapped so that you can have, let's say, the video camera draw directly into these buffers and then pass them on to the hardware encoder or the video system for displaying on the screen. And this API is now standardized in the kernel, and we have support for these buffers so that different elements can now share the same buffers. Previously, on all the platforms where we had that kind of feature, they had hacks. You needed like special elements that would actually know that these buffers are special hardware buffers. So now these are all should all be integrated. My favorite side, being a video call per guy, originally, is RTP. We have some good things. Finally, we have secure RTP support, so you can have encrypted calls, or encrypted video playback. And that's only symmetric encryption. That's not how you negotiate the keys. I'm working on the Datagram TLS to have, which will be used in WebRTC for the video calls, but that's not up there yet because I'm waiting on the Jita people. We have done a lot of improvement to the RTSP server library. So Gstreamer is all this framework, but there's some higher level libraries built on top of it, part of the Gstreamer project. One of them is more or less everything it takes to build an RTSP server. It's not an application, it's really as a library, so it's easy to integrate with your own application for serving media. We have improved it a lot in the last couple of months for various users, and now it covers almost the entire RTSP 1.0 standard with a lot of features that are, I would say, fringe features, but that were requested by the users. We have some improvements to our developer tools. So, first, previously, our debugging system was based on printf, and we had some special printf modifiers that are a glibc feature. So if you are on a platform that's not glibc, the debug log were much less useful. There are a bunch of messages where you have like numbers instead of text explanation what it was going on. So it was very painful to debug. Now we have a custom printf, so you can actually use them all non-glibc platforms. So that, I think, will will be very useful for people who are working on non-Linux. One of my other favorites, because I wrote them, is called insert bin. So it's an element that you can put in the middle of your pipeline, and it does nothing. It just lets your buffers go through. But you can call APIs on it to add or remove things dynamically in the pipeline in the most simple way possible. So you just call add with an element, and it will insert it, and will tell you when it's been inserted, or if it could not insert it correctly. And you can insert elements. It's like a list internally, so you can pick where you insert elements before some element, after. It's very simple to use. And it makes it very easy to add integration points into your existing pipeline, where you can add other effects or other plugins. We've also improved our geometric introspection support. So this is for bindings for language other than C or C++. The Python ones have seen quite a bit of work. So this is a language, our first fast language for Gstreamer. We also have decent support for JavaScript-based bindings, as this is the official Gnome language for application developers now, I believe. So you should have full support of Gstreamer in there. If things are missing, please file bugs, because I'm sure the thing is that not been tested may or may not work. But there's more and more people using it, especially Python, so that should mostly work most of the time. There's some also some Gstreamer features that were in 0.10 for developers, and that have now been forward ported. So we have support for DexLink cards. These are hardware PCI Express video acquisition cards from SBI or from DVI input to the computer. So we have Gstreamer elements properties. The WS API, it's a Windows thing, to audio, no idea how it works. We have a lot of work has been done on the Nonlinear Editing library. It's called Gnome.ASIA, and that's to build nonlinear editors. And on top of that, there's a library called Gstreamer Editing Services. That's a very high-level library to build a video editor application. And that has seen a lot of work in the last few months to make it better, more not crash, amongst other things. And the API has improved a lot in Gstreamer Editing Services. And the Gnome code has been also made quite a bit better. And also a lot of the less popular plugins that have small effects or stuff. Almost all the plugins are ported now. I'm pretty sure that the ones that have not been ported will probably be deleted in the next cycle, because it means no one's using them. We also have a new thing that we didn't have before. In 0.10, each new version had bug fixes and new feature, and they were all mixed together. So it was very painful for people trying to develop something that's not a desktop application when we wanted a stable version. So now we make stable releases with only bug fixes. So, for example, after the 1.0 release, we have 1.0 dot something, and these are all purely bug fixes on 1.0. We will do the same thing for 1.2, and we like the Linux distributions now have 1.0.7. I think that's the latest one, which has a lot fewer bugs than the original 1.0 with no new feature. So these are the status of the current branches. 0.10, we don't care. We're not supporting it anymore. The community is not supporting it. 1.0, it's only bug fixes. 1.1 is where the work is happening, that's Git master. And 1.2 will be released any day now, probably 12 weeks. There is also a brother project to Gstreamer, the Gstreamer SDK. It's a commercially led project to build a commercially supported version of Gstreamer. So it's the same source code. that was 0.1035, and they went to work together, even though they should have. So now by adding this SDK, we hope that the commercial ecosystem will center around these stable releases. And although I'm saying so also if you're a commercial user and you depend on 0.10, this is probably the branch to go because the upstream branch is not maintained, while the SDK branch still has commercial maintenance, so that people so that Collabora and Fluendo do bug fixes as we get bugs reported by our commercial users. Yeah. So I would like to thank you. I would also like to thank the Gstreamer community who wrote all the code. Wrote up any piece. We are always reachable at freenode on the Gstreamer channel IRC. So that's the best way. If you want to get in touch with the Gstreamer community, if you use Gstreamer, if you have problems, come talk to us. We also have a mailing list you can find on the website. It's called Gstreamer Devil, and it's mostly for developers running applications with Gstreamer. There's also a folder mailing list, Android, and stuff like that. And there's a commercial SDK at Gstreamer.com. So these are the main ones. The SDK is quite useful to like a Windows developer, especially because they have builds, and building anything on Windows is so painful. So yeah. So anyone has questions? Yes.
Contributing Gstreamer, and is there any? I'm just new to Gstreamers, but I'm start to be interested, and just I want to know what is the what Gstreamer part of what part of the Gstreamer has now kind of problem that contributor needs to,
if you look on bugs.gnome.org, we have over 1,000 open bugs.
Yes.
So a lot of them are in plugins. Many of them are like, I have this very weird file that will not play.
Yes.
So that's a lot of bug fixing of the various elements. Also, from the Gstreamer point of view, we're always missing application developers, people to actually use it. Because of the application developers then find out that working on Gstreamer itself is more interesting than stop writing applications. But for example, the PTP application, which is video editor, has a lot of interesting bits and a very active community. The maintainer was at Gnome.ASIA last year, but it's not here this year. What else is there? There's a bunch of things. There's, as I said, over 200 something plugins, and some of them are worse than others. Need more love.